Good morning, students. In the last part, seventh part of solid state, today we are going to study about the magnetic properties of solids. Based on the magnetic properties, solids are classified into five types: diamagnetic substances, paramagnetic substances, ferromagnetic substances, antiferromagnetic substances, and ferrimagnetic substances. Now, what is the reason behind the magnetic property of the solid, or how a solid shows a magnetic property? When a solid is placed in an external magnetic field, it shows mainly two types of behavior. Either it is attracted towards the external magnetic field, or it is repelled by the external magnetic field. So, this magnetic property in solid is due to what? First, we'll try to understand this. You can see in the diagram, and you also know that an electron in an atom has two types of motion. It not only moves in definite shells, but it also spins around its own axis. So the magnetic properties is due to this only. The magnetic properties of different solids are studied in terms of their magnetic moments, and this magnetic moment in solids arise due to the orbital motion and spinning motion of the electron. As you know that electron is a charged particle and it is continuously moving. This motion of electron makes it to act as a tiny electromagnet. So electron being charged and continuously in motion, it acts as a miniature electromagnet. The magnetic moment of the magnetic field generated due to orbital motion of the electron is along the axis of the rotation. The electron also possesses moment due to spin, which is directed along the spin axis. Now, the first type of solid on the basis of the magnetic property is diamagnetic solid or diamagnetic substance. The substances which are weakly repelled by the external magnetic field are called as diamagnetic substances. So solids like titanium dioxide or sodium chloride or benzene are diamagnetic in nature. And this property of diamagnetism is because these solids have all their electrons in the paired state. The second kind of solid is paramagnetic solid or paramagnetic substances. Those substances which are weakly attracted by the external magnetic field are called as paramagnetic substances. And these substances have some unpaired electrons. And in the magnetic field, the alignment of magnetic moment of these electrons develop magnetic property. The paramagnetic substances have temporary magnetism, that is, they lose their magnetism in the absence of the external magnetic field. So cupric ions or dioxygen, they are some of the solids which show paramagnetic behavior. The third type of solids are ferromagnetic solids or ferromagnetic substances. Those substances which show permanent magnetism even in the absence of the magnetic field are said to be ferromagnetic substances. Such substances remain permanently magnetized once they have been magnetized. Means even if the external magnetic field is removed, its magnetic property is not lost. This type of magnetism arises due to spontaneous alignment of magnetic moment due to unpaired electrons in the same direction. So the alignment of magnetic moment of unpaired electrons remains same even after removal of the external magnetic field. Hence, they are permanently magnetized. The fourth type of solids called as antiferromagnetic solids or antiferromagnetic substances. They are those paramagnetic substances whose resultant magnetic moment due to alignment of magnetic moments in the magnetic field is zero. You can see in this figure that the magnetic moment of some of the electrons, they are in the upward direction, let us say in the clockwise direction, whereas magnetic moment of some other electrons shown in blue, they are pointing downwards, say in the anti-parallel direction or in anti-clockwise direction. When these two, parallel magnetic moment and anti-parallel magnetic moment, which are aligned in opposite direction, their net magnetic moment becomes zero, then such solids are said to be antiferromagnetic solids. So for example, MnO or Mn2O3, they are antiferromagnetic solids. So the magnetic moment pointing in both the directions or in opposite directions are equal in number in antiferromagnetic solids. The last type of solids are ferrimagnetic solids or ferrimagnetic substances. These solids are expected to possess large magnetism on the basis of unpaired electrons, but actually they possess small net magnetic moment because the magnetic moments align in parallel and anti-parallel direction in unequal number, and the magnetic moments which are pointing in upward direction or in clockwise direction, their number is more than pointing in anti-clockwise direction. So they have net magnetic moment, but its value is very small. So example like Fe3O4, ferroferric oxide, ZnFe2O4, CuFe2O4 are some of the ferrimagnetic solids. So with this we come to the end of the solid state, the first unit of your chemistry.